Geologist working at the intersection of AI and critical minerals. For the 10 years prior to joining Jotaware, a software firm, I was a research geologist at the US Geological Survey working on critical minerals and resource assessments. Over that time, I saw an increased attention being paid to critical mineral supply chain issues as well as domestic resources. And I'm happy here to talk about the value of pre-competitive geoscience information that Earth MRI provides to sound decision-making for the nation. Earth MRI is transforming our understanding of the subsurface, and it's doing so in 3 ways: data, tools, and partnerships. I urge you to consider continuing this program and perhaps even expanding its scope. First, data. The data that Earth MRI provides is a public good, non-rival, non-excludable. It crosses many modalities, including geophysics, geochemistry, geologic maps, and is helping us capture or recapture legacy data, information that would otherwise be lost or locked away in proprietary silos, state geological survey archives, or proprietary holdings. By bringing this data into the modern age, we can leverage the best of what we already know with this newly acquired geophysical data, geochemical data, and other modalities. This enables us to then utilize tools. So tools that have only recently been developed since the advent of the program in 2019. If you had asked me then if I thought the 2031 deadline was achievable, I would have considered that to be pretty daunting. But now with AI and ML, we can expedite many different processing steps as well as interpretations of that raw geological data. Going back to a quote from the illustrious geoscientist Gilbert in 1903, "Those who labor for science do 3 things. They observe, they classify, and they explain." The motivation for this is not just an increase of knowledge, but it is also an increase of welfare. Observations like those coming from Earth MRI are a key input in our models. Classification is something that can be solved with AI and ML, but explanation relies on partnerships and workforce. And those are the 3 things that Earth MRI is delivering. The last part, partnerships. Partnerships between state surveys and the US Geological Survey are essential for carrying out the work. Partnerships between industry and those other stakeholders are also essential. And we're developing new opportunities to grow the critical minerals workforce, something the National Academies has published extensively on. Altogether, these components make Earth MRI an essential part of the federal minerals dialogue. It also continues to provide value for industry by de-risking mineral exploration projects and attracting investment into jurisdictions that may otherwise be overlooked. So in conclusion, I urge you to consider reauthorization for Earth MRI funding, and I'll leave you with the words of the first director of the USGS, Clarence King, who wrote, "We have only just begun. The great work still lies ahead of us." Thank you.
Thank you very much, Dr. Lederer, for your testimony. I'm ending 8 years in Congress. I have never seen a witness talk like you did without notes. Congratulations. Good job. The chair will now recognize members for 5 minutes of questions. I now recognize myself for 5 minutes. Dr. Lederer, Earth MRI has significantly expanded our understanding of domestic mineral resources. As the program is reauthorized, I believe the next phase of the program should build upon this broad geographic coverage by focusing on higher resolution, formation-specific mapping that can better identify known economically viable critical mineral deposits like the Duluth deposit or Duluth complex rather, in northeastern Minnesota. Can you share a bit more on the value of higher resolution data?
Yeah. So when it comes to mineral exploration, there's always a trade-off between coverage, searching broad, and resolution, searching many different types of data for a smaller footprint. A lot of what the mineral industry relies on is actually the availability of that high-resolution data to de-risk and focus their search space. In an area such as the Duluth complex, we understand the broad regional geology fairly well, but there's a lot of uncertainty that could be reduced by collecting those higher resolution data sets. And in particular, new sensing modality that allows you to see deeper, that allows you to penetrate into the crust, upper few kilometers, and better understand both the lithology, but several other factors. In fact, there are 6 physical factors that are important for mining: grade, tonnage, depth, location, grain size, and mineralogy. And really, you need a series of different tools to understand each of those components and make good decisions about the physical resource.
Thank you. Dr. Lederer, as AI and other emerging technologies continue to advance, do you believe Earth MRI is collecting the right data, or does the program need to expand beyond traditional mapping approaches and focus more on this higher resolution data, as you just explained?
I think the decision to collect airborne geophysics is appropriate because you can collect a lot of data over broad areas very rapidly. As we move forward into better understanding and characterizing those focused, targets for exploration, there could be more to sample both at the surface and the subsurface. There could also be more partnerships with industry who generally focus at that smaller scale. So again, in general, there's this focusing that occurs as you develop an exploration prospect.
Thank you. Mr. Levin, as well, as we all know, mineral extraction can be an incredibly expensive and capital-intensive process. In your written testimony, you discuss Earth MRI's return on investment and allude to how the program is helping the domestic industry de-risk domestic mineral development. Can you expand on how Earth MRI is enabling our domestic mining sector?
Yes, sir. This data at this resolution, and it's several different data sets. And again, I am a mapping expert, not a geologist, but it's hyperspectral imagery, it's 3D LiDAR technology, and this airborne geophysical data. Those data sets together provide that resolution and richness of data that allows us to zero in and target where some of these deposits are, whether in the past technology did not allow that, or helps us better define it, which again